Swift 2.2 is almost here, along with Xcode 7.3, and it brings with it some new features, some changes, and controversially many deprecations, which means older code may now have a warning next to it in Swift 2.2, which means in the future, Swift 3.0 or later, it will be removed entirely and no longer work. This video is designed to guide you through these changes with hands-on code examples so you can get ahead of the game. If you prefer reading rather than watching a video, this is all available online at my website, hackingwithswift.com/swift2-2. I hope you've already seen my article and video, What's New in Swift 2.0, linked here. And of course, the book itself, Hacking with Swift, is really awesome. You should go and check it out. Please follow me on Twitter. I am @2straws. And now, let's get into some coding. Starting with the easy stuff, deprecations. So, the postfix and prefix operators plus and minus are deprecated in Swift 2.2, which means if you write var I equals 10, I plus or plus I, you will get warnings when this code runs, like that, saying, yes, it's deprecated, it'll be removed in Swift 3. And that also applies, of course, for minus, like that, postfix or prefix, both are now deprecated. Now, of course, this isn't really a problem because these things are easily replaced with minus equals 1 or I plus equals 1. And ultimately, the number of characters you're writing is barely changed, so it's not any harder, but it is significantly easier for beginners to read. So I agree, this is a smart change to make. Go ahead and change your code. Also deprecated are C-style for loops, which look like this. For var I equals 1, I is less than or equal to 10, I plus equals 1, like that. And in here we'll just print a message out, so we'll say print I green bottles, like that. So it'll loop from 1 up to including 10 and print out a message. And you'll see again, warning pops up, C-style for statement is deprecated and will be removed in the future version of Swift. Notice future version of Swift, not Swift 3.0, at least not currently. So it's maybe Swift 4, Swift 5, Swift 10, we don't know. It's going to go away though, so please rewrite your code. Now, fortunately, there are a number of options, much more Swifty options we could have written in here for I in 1 to 10. That'll do exactly the same thing. Boom, like that. But if you are going to do this with ranges, please remember you cannot write reverse ranges like you could have done with a C-style for loop. So say for I equals 10 to 1. This will compile, but it will crash. Hopefully, there we go. I think it's just crashing just there we saw. That is just, you cannot make, there we go, an actual crash. You cannot use reverse ranges. It will crash at runtime like this, which is bad. So if you really want to do reverse ranges, you should write them as 1 to 10, like that, in brackets, and then reverse. So you'll get 10 through 1. All being well. Come on, Swift, you can do it. There we go, 10 to 1. Fantastic. Of course, you can just use regular fast enumeration. We could have written in here for array equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then written for I in array, like that. Same result would happen. Although if you too want to write that, if you want to be technically correct, which of course is the best kind of correct, you should really just write array 1 to 10, and you get the same result. So that is the new removal of C-style for loops. And let's move on. And you may have noticed by now I've been using var array here, and we have this particularly ugly output, 1 green bottles. It should be 1 green bottle, which gives me a chance to demonstrate a new method inside arrays called remove first. We've always had array.remove last to remove the last element in the array. We now have array remove first as a complement, which removes the first item in an array, which is perfect because you can now see 1 green bottles has gone away. Fantastic. Fixing bugs while demoing features. I love it. I should warn you though, if you look at the signature for this thing, remove first, it returns an integer, because this is an int array or a string for string arrays and so forth. It is not optional, which means if you have an empty array, it will crash. So if you have var array equals string and then array.remove first, boom, you'll get a crash in your code. Not a compile error, a crash. So watch out for that. Right, enough of these things. Let's look at tuples, or tuples, or tuples, depending how you pronounce them. So Swift 2.2 introduces tuple comparison. So I can say let singer equals, let's do Taylor, and Swift, and then let alien equals, another tuple, Justin, Bieber, like that, boom. We can now compare these tuples directly. We can say in here, if singer equals alien, then print we got matching tuples. Hooray. Else print non-matching tuples. Tuples. There we go. And that will compile and run, and it will say non-matching tuples. They are not the same thing. Now, before Swift 2.2, you could compare these tuples, but you had to write your own comparison code, which is pretty ugly, and I've given you the code for that in this article. And it only worked in our example code for tuples with exactly 2 items. In Swift 2.2, this comparison works up to 6 elements in a tuple. So you could say 26 and 52, and it will compile and run and work correctly. If you want to know how this works, simply try and compare non-matching tuples like this. Let's do 26 Swift. You see a large error message like this, but at the end you see the important stuff. So it can compare AB, AB, ABC, ABC, ABCD, ABCD, ABCDE, ABCDE, up to ABCDEF, ABCDEF. What that means is it can compare tuples containing up to 6 items, which is called arity 6. And there's a reason for that. I can't do 60 or 60 million, or how many items in a tuple. Each one of those comparisons is literally more code inside the Swift standard library. And the more comparisons you add, the more size you add to the standard library, which is a bad thing. So that is tuple comparison. And sticking with tuples for one more moment, there's a change that's been removed, deprecated, in Swift 2.2 called splat syntax, tuple splat syntax. It's a lovely name from Chris Latner, and it's been there for years. So if I write a simple function for you called, let's call it describe person, which will take a name, which is a string, and an age as an integer like that, and we're just going to print out what it is. So we'll say print name is age years old. And of course, we call this by saying describe person, Taylor Swift is 26. Boom. And it would call that method, function, and print out over here, Taylor Swift 26 years old. Brilliant. That is a simple function call inside Swift. Now, unbeknownst to many people, I would wager most people, is tuple splat syntax, which looks like this. Brace yourself. Let person equals Taylor Swift age 26. This is a tuple. This is not anything special here. It's a tuple with one unnamed item and the second one 26 with the name age. We can pass that into describe person. Even though it expects 2 parameters, name and age, we can actually just say person and get the exact same result we had before. Swift understands it wants to parse this tuple directly into the function call as these parameters, and it will work. However, Swift 2.2 will give you a warning sign saying this has gone away, deprecated, stop using it. Does not say when it's going to be removed entirely. That may change, of course. I expect Swift 3.0. So even though it's a neat little hack, do not get too friendly with it because it's going to go away. Moving on, let's talk about argument labels. Now, as a reminder, argument labels look like this. For I in 1.stride, and we'll do stride through 9 by 2. We can print something out. We'll just do print I, okay? And that will print out the numbers 1, 3, 5, 7, 9. This is an argument label, and so is that. And these help Swift be self-documenting. If we just written, 1.stride 9, 2, like that, what does that mean? It could mean anything at all. So with these labels in there, we can now be very clear. We mean up to and including that, moving that one each time. And actually in Swift, these things have a functionality difference. You can see 1 through 9 by 2 gives us 1, 3, 5, 7, 9, whereas 1 to 9 by 2 will give us 1, 3, 5, 7. So there's a different result here. These labels matter. And of course, we can give these labels to our own functions in Swift. But in Swift 2.2, this has changed slightly to be better because you can now use a wider variety of names for your argument labels. Things that were previously reserved are now mostly not reserved. I'll give you an actual example. We'll do func print greeting using name as a string again, and we want to repeat this greeting a number of times. So we're going to call our label repeat and repeat count int. And we'll just do for underscore in 0 up to but not including repeat count. We'll do print name like that. You can call this by saying print greeting Taylor repeat 5 like that. And this will just print the name Taylor 5 times like that. Now, this is the new thing here. We're using repeat as our argument label. And before Swift 2.2, this would not have been allowed. You'd have to write repeat in backticks to mean, I don't mean the keyword repeat, I mean repeat as a special argument label for me. And now that's been a warning. This does no longer have to be escaped using the backticks, replace without backticks like that. So you can now use argument labels that are keywords like repeat, or like do, or like catch if you want to, or in. You know, when you have a method called find view in array, you can now have in, which makes much more natural reading for people when they're reading your code. This is not every keyword. You may not use var, let, or in out. Other than that, everything is fair game. Speaking of var has changed as well, because it used to be the case when you get a variable like name here to use inside a function, you can see it here being used, print name. If I want to modify name, I couldn't. I would say something like, name equals name dot uppercase string, like that. It won't work because it's a let constant. These things are passed in as constants. So you can't modify them as variables here. It doesn't work. Before Swift 2.2, you could have written var name, which meant make this thing variable when it comes in. And now it's printing out Taylor in uppercase. However, here's the warning symbol, a red underline. Yes, the var has been deprecated and will be removed in Swift 3. So don't use it. Now, the reason for this is fairly straightforward. Var was very confusing because of things like in out, which has a similar but not the same meaning. And this confusion was causing problems for people to the point where I actually included it in my Swift test. If you haven't seen it already, I wrote a little test at http://hackingwithswift.com/test to test your Swift skills. And in there, I included a var example because I know it's sneaky because a lot of folks don't understand it or confuse it with in out. Anyway, it is gone because it is confusing. Hooray. Just strip out all the nonsense we don't need like that. There we go. Fine. So back to our working Swift 2.2 greeting again. You used to be able to say something like print this is online and then use the magic debug identifier __ line __ like that. And then again we'll do __ function __ like that. Oops. Like that. Boom. And you'll see it's telling us it's on line 10, which it, of course it is, of print greeting repeat, which of course it is. This is called, if you're wondering, the screaming snake case structure, which is because it's all uppercase with there's underscores around it. It's very ugly. It's not very Swifty. So it's been replaced. These are now deprecated in Swift 2.2 and replaced with hash line, hash function, also hash column, hash file, all sorts. So let's do in hash file. Boom, you'll see a large sort of Swift playground file being printed out. There we go. Lovely. So you can see that's much easier to read, and it matches what we see elsewhere in Swift in, for example, the hash available syntax introduced in Swift 2/iOS 9, that release there. And in fact, the official Swift review says this introduces a convention where hash means invoke compiler substitution logic here, which makes a lot of sense. So that's the new hash symbol being used here, or octothorpe if you're a real sort of linguist. This also exists in another change they made where stringified selectors are deprecated. I'm going to switch temporarily to an actual Xcode project, albeit a very simple one, to demo this for you because it's important. You used to be able to write things like navigation item dot write bar button item equals UI bar button item stuff, and you'd say, well, let's do title is tap me, style is plain, target is self, and select is button tapped, like that. Boom. Oops. Now, that's how it used to look, how it used to work, but this was imperfect. There is no method called button tapped. I haven't written one yet. But in Swift 2.1 and 2.0 and earlier, it wouldn't warn me. This is just a plain string being mushed into a selector. As of Swift 2.2, this syntax has gone away. It's replaced with another # syntax, hash selector, like that, button tapped. No more quotes required. That is a new way of writing it, and immediately we get a compile error. This will not build anymore because it cannot find button tapped. You must write func button tapped first, and now it will compile correctly. So it's a huge improvement. If you make a typo here, button taped, whatever, it will no longer build, as opposed to a string which could contain who knows what. Big improvement. Another whole type of bugs gone away in Swift 2.2. Let's go back to the playground again. I want to demonstrate just one last thing to you, and that is compile time Swift version checking. You can now write hash if Swift and then a number. So we'll do greater equal to 2.2, like that, and then else, and then end if. And in here we'll say print, running Swift, running has 2 ends, or 3 ends, sorry, Swift 2.2 or later. And here we'll do Swift 2.1 or earlier. Boom, like that. And it'll print out running Swift 2.2 or later. Now you will notice it is hash if Swift, not if hash Swift. So there's 2 distinct classes of the pound symbol being used here. If it is hash if, it is a build directive. This literally changes the code that is being compiled. When this is run through a Swift compiler, it sees only that line. This line does not get parsed, touched, diagnosed, anything. You can literally write utter gibberish here and it will still work. This code can be absolutely anything you want and it will be completely ignored because it's not seen by a Swift 2.2 or later compiler. Now, you may wonder why this is needed. That's because if you think about someone who handles a framework or a library who wants to support Swift 2.2 and 2.1 and 2.0 and who knows what, because their users or their customers have multiple versions, this is perfect. They can put everything into one file and the Swift compiler on the end user's machine will choose the correct version intelligently. So this syntax, hash if Swift, is very similar to the hash if OS stuff you can do to detect which OS you're running on, and very different to hash available or what we saw just a minute ago, hash selector or hash line. So that's what's new in Swift 2.2. I hope this video has been useful. As a reminder, you can read it all on this URL just here, or read the Swift 2.0 changes here. Please do visit the rest of the site, hackingwithswift.com. It's full of tutorials, completely free, as well as a great book you can buy. And of course, you can find me on Twitter. I am @2straws.